Okay, here a navigation problem that we'll use right triangle trig to solve. A happy sailor travels at a speed of 30 knots from Fort Lauderdale on a course of 65 degrees for 4 hours, and then changes to a course of 335 degrees for 2 hours. Determine the distance and the bearing from Fort Lauderdale to the boat. Okay, let's begin with a north-south line to help us draw the bearings. And we can put in Fort Lauderdale down here. The boat travels at a course of 65 degrees, so we've got an acute angle here. We'll approximate it going this direction. So we have our 65-degree angle here. Then the boat changes course, so I'm going to draw in another north-south line so that we can again find the bearing. The course is 335 degrees. That means we're just short of a full circle by 25 degrees. So we have our boat going in this direction. That means we've got 25 degrees here, because remember the bearing is measured from the due north going clockwise, so we go 335 degrees all the way around. Now we want to know the distance from Fort Lauderdale to the boat. So to do that, let's finish this triangle. And we're looking for this distance x. We can first look at the distance on each of the legs of the triangle. So we have 4 hours at 30 knots. That's 120 nautical miles. I'll abbreviate it with NM for right now. On this side, we're moving for 2 hours, so that's 60 nautical miles. And we have a right triangle here. Let's take a look at y. So knowing the alternate interior angle theorem, if 65 degrees is here, we have two parallel lines. The alternate interior angle is also 65 degrees. 25 plus 65 is 90. That means we're left with another 90-degree angle, or a right angle, in our triangle. So for that, let's solve for our hypotenuse of the triangle. We've got x squared equals 60 squared plus 120 squared. That means x is the square root of whatever that is. X is approximately 134.2 nautical miles. And this one previously, of course, was 18,000. Okay, the tricky part here is finding the bearing. And of course, we have to know what it means. What are we looking for? That is, if we're at Fort Lauderdale, we look north. To know the bearing from Fort Lauderdale to the boat, we have to look clockwise from there. That means we're looking for this angle right here. We're looking for theta. But that's not inside of our triangle, so it's a little challenging to use that. So the first thing we're going to look for is the angle inside of our triangle. Let's call that y for right now. So tangent of y will be equal to 60 over 120, the opposite over adjacent. That means tangent inverse of 1/2 is equal to y. And if we calculate that for y, we get that y is approximately 26.6 degrees. But remember, that's not the bearing. What we want here is theta. Now theta plus y is going to be equal to 65 degrees, given the bearing originally in the problem. So for the bearing, we can find 65 degrees minus 26.6 degrees to get a bearing of approximately 38.4 degrees.